founded Comet, it was with the notion of where are the drivers in this whole renewable space, and where can we add value? And we very quickly came to the conclusion that this is significantly about the cost of sugar. And if you can get to competitively cost sugar, you can do anything. And if you can't get to competitively cost sugars, you can still do anything, but again, no one will care. So we wanted to tackle the key drivers of getting to low-cost sugar. And we started from the standpoint of we didn't want to use anything that hadn't been proven somewhere before in some similar application. We didn't want to use unproven unit operations, and we didn't want to use things that didn't work. And so we started with that, and then we wanted to hit some of the key operating cost drivers, which are if we can make these plants directionally smaller catchment areas, less transportation distances for biomass, we can hit a key operating cost. And then we went looking at the operating and production costs around getting to low-cost sugars and competitive sugars. We developed some intellectual property. We demonstrated the technology at a demonstration facility that we have access to at a partner site. And now we are looking at opportunities for the next step for us, which is commercial demonstration of a first facility that will operate 24/7, improve costs, and get to that what we would call an inflection point, whereby we have proof of the concept, proof of the technology, proof of costs on a scale, proof downstream, and then that lets us look at other things. We've recently closed the financing to get us to that point, and so we come at it very much from a commercialization standpoint. So we think about the drivers that everyone thinks about in terms of why we're doing this and why we want to be in this space: diversifying away from petroleum resources, climate initiatives, and sustainability. We believe that technologies downstream and upstream from us are now at a point that it makes sense, and we want to try and do things that make sense, take advantage of natural resources, take advantage of all the things that make sense in terms of the renewable space. And so from our standpoint, we see an awful lot of challenges, and we can impact on those challenges. And just to kind of start from the very much other end. So we very much see from biomass through to that key intermediate into building blocks and chemical products. And some of the challenges around those chemical building blocks are around product specifications, scale requirements, manufacturers that don't like to do things until they are proven. Bringing that back to if we're providing sugars into that space, again, we have production specifications, quality specifications we need to meet. These materials are affected by commodity pricing in general if we're talking about corn-based sugars or cane-based sugars. And so we need to be able to be competitive and also meet the demands downstream. Biomass tends to be non-uniform. It tends to have contaminants in it, dirt and rocks and other things. There are, of course, issues with storage and transport. Composition of biomass changes field to field when you harvest it. And those compositional changes affect us because we want to get down to sugars eventually. And so getting from this point over to this point requires not just cost competitiveness, it requires a technology that has some advantages and addresses those needs. And so from our standpoint, what we've tried to do is work that into our design and how we run this process. We very quickly determined that we want glucose as a main product stream. And so we're more of a cellulosic glucose technology company than a cellulosic sugar technology company. Glucose has wide range in existing markets. It's a well-proven material. And in our process, we get to a relatively high purity glucose stream. And so it's important to us to be able to do that. It's important to us to obviously be able to do that with competitive costs. And so we've come up with a process and a sort of some tenets that we live by in terms of making these operations simple, robust, and operable. If you want to have a facility that will work on an inconsistent feedstock, despite our best efforts to make it consistent, it needs to be simple. It needs to be able to take different types of materials, ash, abrasive materials. It needs to be able to handle dirt. It needs to be able to do that in such a way that it doesn't break, it doesn't stop, it doesn't need a lot of maintenance, it doesn't have to have 10 people crawling all over it with wrenches or PhDs to run it. It has to be able to do all those things. And through our demonstration facility and our past experience, we have good operating experience in how we do that. For us, we see hemicellulose and lignin as co-products in various different applications. And so for us, we've paid a lot of attention to risk mitigation. Our demonstration facility will run, depending on the biomass feedstock, between 5 and 10 dry tons per day through that facility. We see commercial scale size, sort of minimum commercial scale size of about 20 times that amount as opposed to 100 times that amount. And so we're trying to mitigate risks as we scale. So we're looking at a platform technology for us that will take biomass crops or residual straw and stover, the gas, for instance, cane trash in different parts of the world, into separating into these the key streams that we see, which are glucose, hemicellulose, and lignin. And there's the significant existing market for not only just biofuels but biochemicals, because of the way we run the process and the glucose that comes out of the process. We can look at some of those higher value-added applications, and it opens up a wider range for us. That is a significant market before getting to all the promise around biochemicals, bio-based plastics, and the like, which is certainly a significant growth market and good examples of commercialization happening right now. We look at hemicellulose and lignin as lower value initially, and then hopefully higher value as we progress. And when we thought about glucose as a stream from biomass, which has many streams, we wanted to come at it from a standpoint of making the economics of the process work so that you could just sell glucose and you didn't need to be able to sell the co-products into higher value added applications. And it's not that much different than how the oil industry started 150 years ago. They made lamp oil and burned everything else. They added gasoline 40 years later, and then they upgraded to other things as well. And so if we have economics around a process that runs, produces glucose, and gets to lower value materials, we can always come back and valorize those streams and add value and do all those good things. So we see specifically, the writing's probably a little bit small, so we see opportunities for hemicellulose in things like animal feeds as a feed molasses, lignin obviously in terms of its energy production, but then also being able to put back on fields, soil amendment, those types of things. And then future opportunities in higher value-added chemicals and higher value-added opportunities that are based on the functionality and performance of those different materials. But we also think, because we are in the middle of that value chain, we think in terms of how we integrate in feedstock strategies that let us be flexible and let us think about where those co-products can return. So on the very far end of the slide, within our process, of course, we see glucose as a major stream into bio-based fuels and bio-based chemicals. Those co-products could go forward into those streams, but we have an opportunity to integrate backward into the value chain and backward into some of the things that happen in the agricultural community. And so there are some opportunities, again, with molasses streams from this process, with opportunities to bring lignin back into the fields and not just hopefully burn it for relatively low value energy. And we think about that in terms of how this better integrates closer to the ag community, and then also provides useful products forward to those people that want to see sustained, consistent materials and of competitive pricing. And so we look at this as removing one of the pinch points in the value chain, of getting from the farm through to end products. We look at it in terms of how it can help integrate, how we can think about not only from field to end products, but other things that happen within the community in terms of the cluster, in terms of enabling those types of things. And then also looking at how we can take what is a wonderful a wonderful resource here in Canada, whether it be ag-based materials or wood-based materials, through to being able to make products that can be exported, technologies that can be exported and the like, and creating value through the process. We see that there is an opportunity, and a significant opportunity, to develop this technology at home. We are a Canadian company, proudly so, and there are tremendous opportunities, I think, here, and all the work that's happening with the group that's in this room in terms of creating clusters and creating the value chain that James spoke about. We see it as a wonderful opportunity here in the region, and of course we also see opportunities around the world in terms of exporting technology and looking at opportunities. And there's abundant amount of material in North America as well as in other places. And as these markets grow and as end product markets grow, we see significant opportunities with the technology.